All right, hello, welcome back. We finally made it to the division unit. I can't believe it. Unit 4 is over, on to Unit 5. And there was a little confusion with our new method of dividing, so I want to give you a video to show you what we're talking about. But basically what you're going to find out is you parents out there learned one method for dividing. It was long division. That's what I learned. That's what you learned too. And this new method that I'm teaching them is more of an expanded form powers of 10 division. It is way simpler once you get used to it. Also, it gives you a lot more options for dividing. In other words, the old method that you and I are used to, you have to get it right. You're getting your divisors, and when you're putting your quotient together, if you mix up a number and you don't know your multiplication facts, you're dead in the water. This new method, that's not the case, so you have opportunities to just go through the way you know your division problems and the way you know your multiplication problems, making division a lot more accessible to everybody. Okie doke, here we go. This is going to be for homework 5-1. I'll go over a couple of these problems with you. Don't panic. It's going to take more than one time to learn how to do this, so don't panic if it looks like a foreign language to you the first time you see this. It's gonna, because it's brand new. It is a foreign language, but once you get used to it and you understand the base 10 method, it's going to be so much easier. You're going to love it. So let's check this out. Oh, I bet you thought I was going to stay upside down. I did not. See, I learned. I got to turn the camera over. There we go. Let's see. Problem number, let's start with problem number 2. 7,548 divided by 8. I'm going to hold my paper this way because I'm going to need some room to go across. And I'm not going to fold in quadrants, which is something new because I always make the kids fold in quadrants. This style, we're going to need a little more space. So 7,548 divided by 8. Now forget about the old way that you were thinking of. We're going to do something new. I'm going to turn this into a box just like we used to with the box method for multiplication. This is going to be a box method for division. We're going to start out asking similar questions like, does 8 go into the number 7? It does not. Does it go into 75? So this means you need to know your multiplication tables. So 8 times 9 obviously would be our closest one, which is 72. Let's see what happens. 8 times 9 is 72. 8 times 900 is 7,200. That's just using our powers of 10s, just like we did in multiplication. Subtract the whole thing out. 8, 4, that's 348. We're going to go over another box and bring our 348 up. Alright, does 8 times anything equal 3? No. What's the closest to 34? Well, 8 times 4 is 32. So 8 times 40 is 320. Subtract that out. 8. I got a 28. New box. 28. Does 8 times anything? Nope. 8 times anything equal 28? Well, the closest I can get is times 3, which is 24. So that means I have a 4 of a remainder. We're almost done here. If you just check this out, it's 900 plus 40 plus 3. That equals 943, remainder 4. All right, let's try this problem again. So we got through this problem doing an expanded notation form of division. Let's pretend, though, maybe you're not so strong on your 8's tables, and that's what's holding you up. In the old method, if you didn't know this part here, to start with a 9, you're dead. You're sunk in the water. This new method, not quite. You can do something different, and you're still going to get the right answer. Like, there's more than one way to approach this problem. If you look at 7, 5, 4, 8 divided by 8. I'll do it in green so you can see the difference. Same problem, different approach. Let's say I'm not comfortable with my 8s. Well, I can do 5s. Everybody knows 5s. So I'm just going to take a stab at it and say 8 times 5. I'll make it 500. So you can go 5, 10, 15, 20, 25, 30, 30. If you have to do that. At least everyone can do that. Instead of 40, it's 4,000. leaving me with 3,548. No problem. And the old algorithm, if you started with a 5 instead of a 9, you're already dead, sunk in the water, can never get the problem right. This one, it's really not a problem. Let's say, I don't know 8 times what's closest to 35. Let's say the only thing I know is 8 times 3 is 24. I'll do 300. Alright, now I can subtract out. 8, 4, oh, got 1, 1, 4, 8. No problem. Alright, 8 doesn't go into 1, but 8 goes into 11 once. I can see that. That makes 800. Subtract it out. 348. If you notice, both problems got to 348. How do I get from the 3? Okay, so 8 times something is closest to 34. Okay, let's stick with, well, you knew 8 times 3 was 24. Let's use the 24 again. $108. Okay. Might be longer, but you're going to get it right. It doesn't go into 1, but it goes in there once. 80. I got 28. Perfect. I know 8 times 2 is 24. 8 times, excuse me, 8 times 3 is 24. Remainder 4. So 500 plus 300 plus 100 plus 30 plus 10 plus 3. 8, 9, 43. Oh, look at that. It may be longer, but it's very simple work, and it relies on what you do know, not on what you don't know. So this one is far superior because it shows you can get to the same answer more than one way, giving more people access to division. Alright, just in case you haven't had enough of me yet, let's do one more problem quickly just so you can see the process one last time before you're on your own. We'll do problem 5, 5,857 divided by 7. Let's go for it. I'll do it the box method. I'll stick with what I know. Everybody, all the kids know 7 times 7 is 49. So even though, I might be able to get closer, I don't know. I'm just going to go for what I know. That's 49. Give it a shot. 7 doesn't go into 5, but it goes into 58. We'll try 7. 7, 5. I got 957. Not bad. Let's do the next one. 957. Okay, does 7 go into 9? Yeah, it does. Once. So instead of 1, I'll do 100. Instead of 7, I'll do 700. 7, 5, 2. Perfect. I have 257. See, if I didn't know this ahead of time in the old-fashioned method, we would have already been sunk. This way, doesn't matter. You're still going to be perfect. 7 times 1, 7 times 2 is 14, 7 times 3 is 21. Let's do a 3. 47. Well, I already knew 7 times 7 was 49. That's too big. So we'll do 7 times 6, which is 42. And we have a remainder of 5. 5 is smaller than 7. Now all you have to do is add them all together. It's 836. Remainder 5. Much easier than the old-fashioned method. In the old algorithm, if you didn't go 8 first, see, this number would have been 8 first. If you didn't know to go 8 first, you're dead, sunk in the water, can't get it right. In this one, you're not wrong, you're perfect. You're going to get to the right answer. Use this method. It's going to benefit you.